Hello everyone, welcome to One Stop Mathematical Solutions. Let's continue the MCQs of 2017 IIT JAM. We are given a function which satisfies the conditions of Rolle's theorem, and we need to find for which values of P and Q it satisfies. So what do you mean by satisfying Rolle's theorem? It means the basic two conditions are it should be continuous first in a closed interval minus 1 comma 1, and it should be differentiable in open interval minus 1 comma 1. So those will be the first two conditions of Rolle's theorem. So what do you mean by continuous? The left limit and right limit of the function approaching 0 should be equal to the function value at 0, right? So limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x, and that should be equal to f of 0. So let's start finding that out. Limit x tends to 0 minus f of x, when the value is on the left hand side, which is less than 0, it is given to be 1 plus x, and applying the limit value we get 1. The right limit, when x tends to 0 plus the right side of 0, the function is given to be 1 minus x px plus q, and applying the limit value we got 1 minus 0 p into 0 plus q, so that will be q, and it should be equal, right? So we will get q equal to 1. Great. Now let's go to differentiable. It means that so the left limit of derivative should be equal to the right limit, where h is some positive quantity. So let's try to find it out. Limit h tends to 0 minus f of 0 minus f of 0 minus h. I'm gonna simply put f of minus h divided by h, and f of 0 is 1 minus 0 p into q plus 0, which is q. We have already found that q equal to 1, so f of 0 is 1. So f of minus h, that will be less than 0, right? So the function for less than 0 is 1 plus x. So instead of x, I'm gonna put minus h, the whole divided by h. Don't forget to put the limit. So it's limit h tends to 0 minus. Great. Let's simplify the numerator. We will be getting 1 minus 1 plus h divided by h. Cancelling 1, we got h by h, which is 1. So the limit will be 1. Let's try to find the right limit of the derivative. So limit h tends to 0 plus f of 0 plus h minus f of 0. I'm going to simply put f of h minus f of 0, the whole divided by h. Now limit h tends to 0 plus h is a positive value, right, which is greater than 0. For that, the function is defined to be 1 minus h x. Actually, I'm going to apply h instead. Ph plus q minus f of 0 is 1, the whole divided by h. So we get limit h tends to 0 plus, simplifying this, we get ph plus 1, and then I'm gonna multiply by minus h. So minus h times ph plus 1 minus 1, the whole divided by h. So the remaining we got, I'm gonna take h outside, and inside we got p minus ph plus 1, the whole divided by h. The h is getting cancelled. So applying the limit, we are left with p minus 0 plus 1, which is same as p, I'm sorry, that is a minus up there, so it will be p minus 1. So let's equate that to the left hand limit. So it will be p minus 1 equal to 1. So p will be 2. So the pair p comma q will be 2 comma 1. Let's check that with the answers given. 2 comma 1 is option D. So option D is the correct answer. Next question, we need to find limit t tends to infinity of integral from 0 to t x square e power minus x square dx with the value of the function, the integral of e power minus x square dx is given. It's actually an indefinite integral, that's why we have a limit t tends to infinity. So let me take the limit t tends to infinity integral 0 to t x square e power minus x square dx as L. I'm just giving it a name. I'm going to start with a simple example. Let me start with 1 into e power minus x square dx because that's kind of thing that's given, right? So I'm going to start with that. So let's integrate it with the UV format, UDV format. So I'm gonna take e power minus x square as u and dx as dv. We know that whenever we have this integral u dv, the formula is uv minus integral v du. Here u is e power minus x square, so du will be minus 2x e power minus x square and dx. And dv I'm gonna take as dx, so v will be simply x. So applying that formula here, first we have uv, so e power minus x square into x minus integral v du, x into minus 2x e power minus x square dx. Great. Now let's apply the limits. So the first one will become e power minus t square into t minus 0 into something, so that will be 0. So let's go to the next integral. It's actually plus 2 into integral from 0 to t x square e power minus x square dx. Remember we started with a simple integral e power minus x square dx, right? But we have ended up with integral x square e power minus x square dx, which is something that we want to find, which is we have already named as L. So let's try to take limits on both the sides so that we can name the second one as L. So limit t tends to infinity integral 0 to t e power minus x square dx is equal to limit t tends to infinity t e power minus t square, and the limit applies to the second term also. So limit t tends to infinity to integral 0 to t x square e power minus x square dx. So the first the term on the left side is what given, right? It's root pi by 2, and in the right hand side I'm gonna write the first term as it is for now. It's we will do it later. It's limit t tends to infinity t e power minus t square plus the last term is actually the term we want. We named it as L, so it is 2 times L. Now let's try to calculate the limit left. The limit t tends to infinity t e power minus t square, if you just apply the limit value you will get infinity times e power minus infinity is 0. So infinity times 0, it is something which is undefined, so we are going to use the L'Hospital rule here. Before that we'll be forming it in a form infinity by infinity form. So I'm gonna write it as t by e power t square, so that when you apply the limit it will be infinity by infinity. Now I hope you know L'Hospital theorem, which states that if the limit is of the form is infinity by infinity or 0 by 0, some undefined form, then you can take the limit of the derivatives, the derivative of numerator and denominator taken separately, and that will be the same answer as the function, right? So here the derivatives will be 1, and in the denominator will be e power t squared times 2t. So that will be 0. So here root pi by 2 is 12, so L will be root pi by 4. So the correct answer will be root pi by 4. Option A is the correct answer. Okay, next question, we have double integral sine y square dy dx. So if you try to do it straight away, you need to calculate the integration of sine y square with respect to y, which you might come up with something like this, which is not that easy to integrate. So let's not do this first. It will be a lot better if you can integrate it with respect to x first. So let's try to change the order of integration. How do we change that? So So here the limits are from y equal to x to 1, and the limits of x is from 0 to 1. So let's try to plot that here. Y equal to x, so that will be a straight line, and y equal to 1 will be a horizontal line at 1, and the next one x equal to 0, which is y axis, okay, and x equal to 1, yeah, that we already know. Now to change the order of integration, which means you need dx first, so you need to go in the x direction first. In the x direction the values goes from 0, that is y axis, right? So the values goes from 0 for x, and it goes to the y equal to x line, which means x equal to y. So the limit of x is from 0 to y. And what about the limit for y? Let's go from down to up. The minimum value of y is 0, and the maximum value of y is 1. The minimum value of y is 0, and the maximum value it can go is 1. So the limit of y is from 0 to 1. So let's write the integration again. It will be integral for the limit for x is from 0 to y, and the limit for y is from 0 to 1, and the integrand is sine y square. Now we can easily start with the integrating with respect to x, because the integrand is a function of y, right? So it will be sine y square into x, and the limits are from 0 to y. Let's apply the upper limit and the lower limit. It will be sine y square into y minus 0. So y minus 0 is y. So we have ended up with 0 to 1 y sine y square dy. Now what I'm gonna do is I'm gonna write sine y square, and I'm gonna group y dy, And let me multiply this with the 2 and divide by the same 2. So we can see that 2y is the derivative of y square, right? So if we need to integrate sine y alone, we will easily put cos y. But what about sine y square? We need to have the derivative of y square, so that we can simply put cos of y square. So that's what we have done here. Now we can apply the limit. It's actually minus cos of y square. So it will be 1 by 2 minus cos of 1 square minus of minus o plus cos of 0 square. It will be 1 by 2 of minus cos 1 plus 1. So the final answer is 1 by 2 1 minus cos 1. So let's check that with the answers given. Option D is the correct answer, 1 minus cos 1 divided by 2. The next question is, we have a function and we need to find whether the critical points have a maximum or a minimum or a saddle point. So f of x comma y is given to be 5 minus 4 sine x plus y square. So let's start with finding the critical points. Here x is between 0 to 2 pi. For critical points, the partial derivatives of f with respect to x and y should be equated to 0. So the values of x and y for which the partial derivatives with respect to x and y is 0 are called as critical points. And from critical points, we can check whether it will be a minimum or maximum or a saddle point. And that we can do later. So let's start with finding the first derivative, partial derivatives of f. So dou f by dou x is equal to 5 is a constant, so 0 minus 4. Differentiating sin x, we get cos x, and y squared, it will be 0. So we have minus 4 cos x, and equating that to 0, we have the first equation. Let's compute dou f by dou y. That will be 0 minus 0 again plus 2y. So it is 2y, and we need to equate that to 0. We have the second equation. Let's solve these two equations. From the second, we can straight away say that y equal to 0. From the first, cos x equal to 0. Now we need to find for which values of x we get cos x equal to 0. If we look at the diagram of cos x, it starts from 1. At 0 it is 1, and at pi by 2 it is 0, and it goes to minus 1 at pi, and again 3 pi by 2 it is 0, and it reaches 1 at 2 pi. So this is the diagram of cos x, and our x is between 0 to 2 pi only. That's why I've stopped up to 2 pi. So the zeros are at pi by 2 and 3 pi by 2. So the critical points will be pi by 2 comma 0 and 3 pi by 2 comma 0. X comma y. Y is already 0. Okay. Now to find whether it could be a maximum or minimum or a saddle point, we are going for a second derivative test. So what is it exactly? You need to find three values. One is dou square f by dou x square, dou square f by dou x dou y, and dou square f by dou y square. And there are three cases. One is if r is greater than 0 and rt minus s square is greater than 0, then that corresponding point is the local minimum. The second case is r is greater than 0 but rt minus s square is less than 0, then we have a local maximum. If r itself is less than 0, that is a third case in which we have a saddle point. Great. So let's calculate the second derivatives now. Dou square f by dou x square, I'm gonna write dou f by dou x first. Dou f, I'm sorry, so dou f by dou x is equal to dou f by dou x is equal to minus 4 cos x, and dou f by dou y is equal to 2y. Let's differentiate it again. So dou square f by dou x square is minus 4 times minus sin x, so that will be 4 sin x, and dou square f by dou y square is simply 2. Now what is dou square f by dou x dou y? You can differentiate either one of them, you will get the same value, 0. So we got three values. One is r, which is 4 sin x, and s, which is 0, and t is 2. So let's calculate these values at r critical points. The first point is pi by 2 comma 0. In that point r will be 4 sine pi by 2, and s will be 0 and t will be 2. Sine pi by 2 is 1, so r will be 4. Since r is greater than 0, it should be either a local maximum or local minimum. So let's find out rt minus s square. So 4 into 2 minus 0, which is 8. That is also 0. So we have a local minimum at the point pi by 2 comma 0. And at 3 pi by 2 comma 0, we have r equal to 4 sine 3 pi by 2, and s is 0, t is 2. But sine 3 pi by 2 is minus 1, so we have r is equal to minus 4, which is less than 0. So at this point we have a saddle point. So we have one local minimum and one saddle point. So option D should be the correct answer, right? A point of local minimum and a saddle. The next question is, we have a differentiable function such that the derivative is strictly increasing with pi dash of 1 is 0, and alpha and beta are the minimum and maximum values of phi in the interval 2 to 3, and we need to find whether alpha or beta matches any of the given values. Remember, it's given that pi dash is increasing, strictly increasing. So we need to start with that. Let's try to take an example to understand what we are trying to do. Let's try to give an example of pi dash, which is strictly increasing and it is 0 at 1. So I'm gonna take pi dash as So the line passes through 1 and it is increasing. So I'm gonna take pi dash of x is equal to x minus 1. You can check that pi dash of 1 is 0 obviously, and this pi dash is strictly increasing. Okay, now let's try to construct a pi from pi dash. So I'm gonna integrate it with respect to x. So our pi of x will be x squared by 2 minus x. Now this function is also strictly increasing because in the interval 2 comma 3 pi dash is greater than 0, right? It is 0 at 1 only. In the interval 2 comma 3 pi dash is greater than 0, positive, which means the function is increasing, strictly increasing. So the minimum of pi will be pi of 2 and the maximum of pi will be pi of 3. Because it's a strictly increasing function, it should go from minimum to maximum. So the alpha will be pi of 2, beta will be pi of 3. In the options, only option A is correct. Other answers doesn't have a correct one. So option A is the correct answer. Thank you. See you in the next lecture.